Okay, I guess we'll get started here. There's a few more people rolling in, so. I don't know if they're like me. I was in the washroom, and the lights went out, right? Had to wait for somebody else to come into the washroom. So I was like, shh. And the lights came back on. It's like, ooh. Could have been very bad. All right. All right, welcome everybody. Thanks for coming. My name is Charles Delfs, and I'm going to be giving a talk on the concepts of syncing. The concepts of syncing. Just a bit about me. I'm from Toronto. Our company is called Delfs Engineering. I'm an electrical engineer originally, and I used to do embedded systems. Those are like small devices and that kind of stuff, and I started developing back then. Learning BASIC was my first computer language, then Z80 assembly language, and moved my way up to 68,000 and a whole bunch of other stuff in between. And FileMaker today, yeah. So there we go. A main focus today is on, for me today is on web technology. We do a lot of web stuff. We have a web-based product, FM Better Forms. We do building things like progressive web apps, stuff that's offline, how to have an app go offline and online seamlessly, and other kinds of hard challenges we take on like that. So I kind of like those kinds of those challenging problems. We have a team of about 14 or so, and a couple of them are here. I don't want to laser pointer you, but they're just in the front here. So they came out, and the rest of our team is virtual, right? The reason we're doing, I wanted to talk about syncs, and we talked about this. Somebody might have saw this talk a little bit before, but the reason I want to talk about it is because we're starting to do a lot more offline stuff, and mostly on stuff with web. But the concepts, the ideas are really, really similar. So. Who this talk is for, this is if you're interested in building some type of a synchronization engine. I'm not going to tell you exactly how to build it. I'm going to tell you about the things to be aware of, the concepts, right? From a real conceptual point of view. And we're going to talk about two main concepts today. Flux type pattern, I'll explain the history and where that's used. And then we're going to talk about a CRDT as well. When it comes to sync, there's no sync that's like, there's not like, okay, this is the sync engine, because one sync here does not work in another location or situation. And almost always they need to be performance tuned and optimized, right? So I hope you can take what you can out of this talk. If you want to continue the talk, if we run out of time or if I go too slow or whatever, then we can meet me outside and we can continue there. And I'd love to hear some of your stories as well. How many people have built some kind of a synchronization thing? How many people have imported something? Should be, okay, everybody's hand should be going up there, right? So we'll talk a bit about the theory, the practical, questions and answers. Oh yeah, hold on, I forgot about this. I wanted to do this because I've wanted to do this for so long. Where's my phone? Sorry, you guys don't mind, do you? I have it ready, just a sec. I've been wanting to do this for so long in a conference. Okay, put your hand up, hey! All right, hold on, one more time, ready? Oh, I don't think I pressed the button. Okay, there we go. Thanks. I really appreciate it. It's like this super cool stuff. I just didn't want to forget about that. Okay. So we'll talk about all this stuff. So let's get into synchronization. It's like to sync or not to sync. All right. When do we really need to sync and when do we not? Most of the time we don't need to. And what I mean by that is a lot of times we can handle things with importing. Right, so you've probably built some kind of system, maybe a FileMaker Go system, and then it talks to the server and it just imports all the changes, and then you sort out those changes on the server, or you resolve the changes, and you figure it out from there. Right? I mentioned no one size fits all. The times that importing is not practical is when it's either too expensive in terms of time, expensive in terms of volume of data, so it's kind of a combination of time or CPU. Or you don't have some kind of continuous conduit, some kind of mechanism between these two things that you're synchronizing. So we kind of have these syncs at these different levels, right? We have between systems, that's server to server sync. You probably use things like mirror sync or I think you guys were just talking about some sync platforms I just heard out of the corner of my ear, right? There's between classes. What I mean, or at least what I'm going to call classes. This is between something up here and a whole bunch of small peripherals some way. I don't know if that's my arm, right? That's how I feel this morning. Between some kind of a server and maybe some bunch of clients, those clients could be FileMaker Go, but they could be something else too. It could be totally other systems. So between peers, this is kind of an interesting one, peer-to-peer synchronization. And we'll talk about some decentralized concepts there. And interconnected components, and we'll talk about a little bit about that too. Interconnected component is when I'm taking, say, my FileMaker server, and I have, say, Stripe or something along those lines. That's not this, right? We're good? Yeah. All right. Okay. So that's another scenario that we need to keep in track, right? In our case, we handle subscriptions, so we have to keep those. You think it's me? No, I don't think so. I don't think so. That's okay. We'll keep working. So that's another scenario. Scenario of synchronized. Check. Who has built something that's synchronizing FileMaker to something non-FileMaker? What was it? Mike? SQL. Anybody else? SQL database? What else? REST API. Well, but where's the REST API is really the interface, but what were you synchronizing to?
The database to another system.
Another external database.
It's a Python built system.
Right. So let's talk about between two systems. Here I got Canada and Italy. I have a good friend who's a developer in Italy, so I use him and I use some other people. I hope you don't take offense to if you see your pictures up here, right? We have the between classes is when either I'm talking from FileMaker to maybe some type of terminal. And the reason I call it classes is because we're going to get into resolving how do we synchronize this information later on. To third-party systems as well, and that's things like Stripe and such. This one's a really interesting one. This is actually two different things going on here. What's unique about this? Anybody know? Like we got, hold on, I want to use my laser here. We got the database here to here. We've all done this. What about this? Yeah, it's peer-to-peer, but this one here is not here. It's not going direct. It's going through here, right? And there's some really neat emerging technologies, actually, for doing this. Some of these conduits in here can be Wi-Fi, point-to-point Wi-Fi, Bluetooth are a few different ones. And there's some technologies, one of the companies called Ditto, and they make a web technology that can, they make a plugin, it's web and also native, that can be used across those devices and synchronize up to the cloud automatically. So that's kind of interesting. All right, so I'll tell you a little bit about how we got I got interested in synchronization. We had a client, and they came to us and they said, we have a whole bunch of FileMaker Go terminals on iPads, and we have a FileMaker server, and they want to have these things, they're all in the field and they're going on and offline, and they upload a lot of documents. They upload like 2,000 documents in a course of a week, right? And they're all taking pictures of these inspections. So they'll take a picture of here and here and here and walk around and take all these pictures. So they wanted to be able to synchronize all of this stuff because they have two, say, workers, say, in this building doing inspections, and the one would be in that room and the one would be in this room, and I'm not sure if I took a picture of the projector over there, but he took that one there, and I want to have that information up to date on my machine. So what they were doing is they would take their iPads all together, they're on site, and at the end of the day, they bring them all, sit them all next to each other. They have an export script running on the iPad, and this is a true story. They would export all of them into a file, and then they airdrop it all into the one main iPad. From airdropping, they would import, they have some custom routines, and it actually works pretty good. And they would import all of its stuff, all of the data back into the main machine, and then export it again from back into the iPads, and then go and take them back into the room. And one person was responsible for doing this in the hotel. So we wanted to see if we could maybe solve that problem. We wanted to build something a little bit more. And they gave us a couple other specifications. They wanted field level resolution. And this is kind of a tricky one because when you're talking about field level, I can change my first name, and then you go in and you change my last name at a different time. That's okay, right? That's easy to resolve, right? We take those two. But then maybe I change my last name as well. I didn't get around to it, I do it. Now, how do I know if it's your changing of my last name or my changing of my last name? Which one is going to win there, right? So we have to come up with some kind of logic, right? We also had to have two to end devices. That means the devices, the idea was that we have some future peer syncing so the devices can talk to each other and synchronize each other to each other, and hopefully using some of these new conduits as well. Have you guys read this before? Everybody heard this before? Two hard things? If you don't, some people are saying, I don't have a problem with naming things. I don't know what you're doing because I have a major problem with naming things, right? Major problem with naming things. Cache invalidation is effectively sync, right? Cache is temporary storage for something. And, like you have your CPU, right? And the central processing unit sits there and it needs some information. It can't read enough. It's too expensive to write to RAM all the time, so it caches it as an interim level, and that cache usually runs at near the clock speed of the CPU. So it's a really quick way of processing stuff because most of the time we're just dealing with stuff here, like local variables, for example. And then when we're done, we can send some stuff out, right? So most systems have some kind of caching built into them that are optimized. So this is really, really true, and I think it still holds true to today. Clay came up to me and says, you're going to talk about how easy syncing is. I said, yeah, that's it, I'm being sarcastic, because it is quite a challenge. There's an expression with cache, sometimes you can't help repeating yourself. And if you've ever built something that has a lot of syncing in it, you're going to end up syncing something and it's like, this data keeps showing up. We just had this in our product the other day. We pushed out an update, and then we would go and hit save, and everything, and it does live updating, so the information came up, and then you'd refresh the page, and it's the old information again, right? And it took us a little bit to figure out where's this coming from, right? But it was some caching that we did. It's the same kind of idea. I want to talk about the flux pattern, and this is an interesting concept, and it's something that you can take away today. There's a few different things we're going to talk about, two different types of syncing. The first one is something that almost everybody can use when you're talking to external systems. So years ago, Facebook, as they developed and their platform grew, they needed a mechanism for all the parts on a page. And I don't have an example of a Facebook page, but you can sort of imagine, you got your likes up here, and then there's, how many shares, and then there's all the comments down here, and there's the ads and stuff over here, and a bunch of other stuff that I'm not sure what it is over there, and so on. So they needed a way of keeping all this stuff reactive, keeping it all in sync. Right? And that's a real challenge in a web page. In the old days, we used to use jQuery. Anybody used jQuery before? Right? Almost everybody. And does anybody still remember how to use jQuery? Somebody. So you mean you're still using jQuery now? That's really what you're saying, right? And we used to wire something up. Like if I wanted to wire this thing here up to some data, I got 3 lines of text. Pretend they came from 3 different fields. In jQuery, we'd have to say, some kind of event listener, maybe that's an input, and we'd add a click, and then it would do some writing. And then we'd do another one, and then that would do some stuff. And it just became more and more complex. You can handle it with maybe half a dozen items on the page. As soon as you get higher than that, it becomes almost exponentially uglier or nastier, right? And you have to start having these design patterns. So Facebook came up with one, and they called it a flux pattern. Flux meaning like the... like eddy currents and magnetic flux, that kind of an idea where it's circular, right? I think that's the concept there. So what they did is they said, well, let's come up with a source of truth, or it's not even really a source of truth, but let's get a source of information, and we'll make sure that the information that we put on the page comes from that spot. So when I change something in my page, somebody gives me a like, that source of information changes, and then that comes down to all the small bits. And that's how most bigger systems are kind of designed here. So here's kind of the concept here. So here we have, and this is something you can use right away. You have FileMaker server sitting over here. We have, say, Stripe Checkout. That's a UI interface for payments. And a Stripe Customer Portal. That's the actual dashboard that you would log into. And you're making these changes in here. So these are user-driven events. And the changes go up. So the concept of flux is that the changes go up into the top, and then the changes come back down. So this is a little bit different than how you probably built connections to Stripe in the past, right? Most of the time when you did something like this, you'd have FileMaker as a source of truth, right? So that's kind of, it's different. Here, Stripe is actually, in a way, more the source of truth, but it's not totally, it's not really the right term, because something can change in here, and that still goes up to Stripe, and then it changes it back, right? The previous talk, I just caught the last few bits, was about like a CRUD type actions, create, read, update, delete. So it's almost the same idea. The webhook coming from Stripe just does CRUD actions, and you have handlers that say, let me handle a customer, let me handle the subscription, let me handle whatever that is, plan, sorry, I couldn't see it, plan handler, and this doesn't actually change the data. This is a weird concept for FileMaker developers. I'm not changing the data here directly. I'm not going to the plan table and changing the plan from plan A to plan B or the customer's amount. Instead, what I'm doing is I'm going and changing some data, maybe globals, calling the Stripe API and changing it. I'm relying on this webhook to come back to change the data back into FileMaker. Right? I'll go do that one again. So I'm not going to edit the tables here, but instead I'm going to tell Stripe, either through the portal or through some other mechanism, that the data changed, and the data changes come back down here. What that does is that keeps your database following Stripe. And in this case, Stripe is a higher class in terms of finance than your database. It's the one that's actually billing the customer, so if there's a mistake in your database, not so bad. A mistake in Stripe, it's bad. Right? Does that make sense? Not so much? A little bit? Right? Okay. So this means that if you're building some kind of interconnected system, don't always think about, hey, I just got to go and make a call to there, and then I got to read the data and stuff. Have the data flow in one direction. When it flows in one direction, not the boy band, clearly that's not popular here. When it flows in one direction, it's much easier to manage. It's a lot easier to manage because this code that's in here is really simple. It basically takes the webhook. Stripe says this customer changed. It passes an ID, and you can pass in metadata through this. And then you just write that data back out into the individual, wherever it's supposed to go, into your tables. All right? So it's a little different concept. That's something you could apply to, try to get that idea of that, and you can apply to it to almost anything that your system is connecting to. Actually, let me just go back one there. Is there any questions just about that concept, that pattern so far? No? Okay. All right. I want to go into another one here, and it's called conflict-free replicated data types. And the thing here is it's data types. This is what we're really talking about, this data type. So it's not just maybe a JSON object, but maybe it's something different than that, right? And the conflict-free we'll get into here. Oops, sorry, wrong way. All right. So in any system where you have to have some kind of synchronization, right? Synchronization is two pieces of data. You want to keep them you want to keep them consistent. And anytime you have that, the minute you copy a piece of information, you could sort of argue at that point it's kind of, the information is potentially stale, right? Potentially out of sync. So we have to resolve that in some fashion, right? So there can be some kind of conflict, something changes over there, my first name, and I need to be able to resolve that. Somebody's got to win, and in order to make it conflict-free, we have to have a preset set of agreements. Okay. So here's an example of two different classes. This one here is trying to resolve it. He was there first. This one feels he's more important, right? I'm not sure if you can understand what's happening here, but it's a bit of a surprise, and it knocks his butt into the water, all right? So that's an example of a conflict where one is by class and the other one is by time. The two of those. So when it comes to resolving conflicts, some of the outcomes are going to be undesirable, almost guaranteed, right? Something's going to be undesirable for one party. So we want to hopefully mitigate that or minimize that. Some conflicts are always resolvable. Those are things that are really easy, right? Some of you probably have built in some type of import routines, and then it produces 7 records out of 1,000 that you have to manually go in and somehow add some intelligence into and figure those things out. Those are the undesirable ones, the other ones that you can do automated fashion. So what are the ways to resolve, right? What are the things? I mentioned one of them is time, right? So time is one of them. Class, in other words, server always wins, for example. Stripe always wins. Those are class ones. Or business rules. Maybe business rules, while a closed account doesn't get changed, opens accounts do get changed. So those are sort of 3 sort of categories of things that you can use to resolve. I'm going to focus today mostly on the time one, because that's the most common, I think, in this scenario for resolving things. Oh, by the way, here's how you can resolve the other. This is how you can resolve the it's like, it's okay. I should have got I'm gonna have to find a picture for my slide where he's wearing a nice wool sweater. So, sorry to the vegetarians. So we have some minimum requirements to resolve something. We have to have the data on either side, or more importantly, the difference in the data. Now, the difference can come in what changed, or there can be an actual difference. Like in certain types of technologies, there's things like called Hamming distance and stuff like that, where you're actually looking at it bitwise and saying, oh, 3 bits changed, and I can kind of compress. That's how all those old modems and things like that worked really efficiently, right? But the data, or the difference in the data, or the delta we'll call it, is required. We need some kind of a locator. The locator is something that identifies that piece of data. It's not enough to know that my name changed from Charles to Jerome, but I need to know that it was my name and it wasn't Andrew's name, and so on, right? So we need the locator, some kind of thing like that. Typically that's an ID, or maybe it's an index, or possibly a table as well. We also need the mechanism that we're going to resolve the conflict with, right? So how are you going to resolve this? Right? Are we going to base it on time, or are we going to base it on the class or the scope, et cetera? So let's look at some examples. I got myself here. I'm from Canada. My good friend Giancarlo, he's from Italy. We have Ian, he's from the UK. And we have Egbert over on the end, and he's from Germany. All right, so we have all 3 of us here. And we're that's kind of geographically accurate, sort of, a little bit, right? So we're going to decide what we're going to have for dinner, right? And Charles, I have my record is ID 01, and I say I'll bring something that's typical Canadian. It's poutine. It's this French fries with cheese and gravy on top, and I'm going to drink some beer. And I want to invite my friend. I want to say, Giancarlo. And he says, okay, that's good, Charles. I'm gonna. It's not a very good accent of him. That's good, Charles. I'm gonna copy your stuff, and I got this information, right? So our information at that point is consistent. But then something happens as he goes offline. He closes his laptop or whatever the device is, and we have that separation. And then he starts to read this. Now, maybe he got that copy in his email, for example, or it's something that he didn't consume it, and he's looking at it now, and he says, hey, I think I'm going to change this to wine, right? They have a nice, I'm from the Turin area. We have some nice wineries here. I'm gonna recommend some nice wine for our thing. So is there enough information? Now we go back online. Is there enough information here to resolve this? You can yell out the answer. It's no. No, right? There's not enough information. So what we need to do is we actually have to augment the information a little bit. And this is the data type that I mentioned earlier. So now, instead of having just the basic information, you can think of this like tables. I drew this as a JSON object, okay? Because I'm not thinking about just tables in FileMaker. We're thinking about concepts, right? So I just drew it as a JSON object to represent the data. But we also added a timestamp. And I created this thing here at 12 o'clock, and I created that field at 12 o'clock. This is a field level information. So we added this metadata in here. And over here, Giancarlo, he got that, and 5 minutes later, he changed the drink from wine to at 12:05. So now we actually do have enough information to resolve, right? So it's now there's no conflict because we're basing it on time. So I take that 12 p.m., and I know that that metadata here relates to a field, right, up here, and now I know which way I can move my data, right? So I have, and I'm not actually even moving the data. This is interesting yet. Right? I'm not moving the data yet, but at least I know what's wrong with my data. Does that make sense? Okay. Sorry, I'd like to move around more, but the gain is way too hot on this mic, so I'm gonna blast your ears out if I do. Okay, so we take that information, and now we isolate that information, and we can actually reduce it down. right? So what we've done is we've taken, let me just go back one slide here. So we've reduced this data down to just the stuff we actually need, right? Why would we want to make the data smaller? Faster, yeah. Everything smaller is less payload. It's less expensive in some fashion, right? So we want to reduce that. So we reduce that data down to just the timestamp, absolute minimum stuff. The locator, the data, this is the difference, and this is the resolution information, right? I added some extra data in here. We technically don't need this based if we have one key condition, right? When could we resolve this thing here when I don't have the table that it came from? What would I need to know? Or what would I need to change? It's like a challenge. Pardon me? Yes, a universally unique ID, right? Now, if it's universally unique, that ID sits only in one place in my destination. So therefore, I don't actually need to know the table. I'd have to look it up, and that's kind of an expensive process. So we just added in this particular case, and in our use case, we added this information in here just to make it a bit easier because it's much harder to look through 50 tables and find a UUID, I think it is anyway, than it is to know the table and just go to that table and find the ID. In fact, we don't usually even find it. We just use a selector and we just write to it. Excuse me. All right, so that's an edit object. And that edit object there has a few factors, right? Edits are really only a request. It's not saying that this is the answer because somebody else could have changed some data too. Right? And somebody else could have all changed data. And we don't know what their data is. We only know this one piece of information at this machine, right? So it's only a request. You can think of it like that. It's only a suggestion. I think this drink should be wine in a 1205, right? That's kind of the only thing there. It contains all the information we need to resolve based on our set of rules. Now, if our set of rules was class-based, this might have something else. There might be some other piece of information in there that says this was a admin, or this was the server, or something like that. So we'd have some more complex information in there. Edits turn into resolution, so we resolve this edit. That means we need to take this to something else, to another machine, and we resolve that. And then we resolve that information, we can take that and we call that an update. So the update is really this information that I can more or less write to the CRUD. Right? And I take that information, I send it to my CRUD, and I write it confidently. And you say, well, wait a minute. How can you write this to the CRUD when you went and changed it maybe some other places and some other places, right? But every change creates an edit, okay? Every change creates an edit. So that means if you change something and I change something, even if I don't get yours, but I get your edit over here, right? I can update from over here. I haven't received his yet. Based on the resolution data, the data that we resolve it with, when I get his, I might have to revert mine, I might have to change mine, or I might disregard his and say, here's my latest edit, that kind of thing, okay? All right, so let's look at it in a little bit more practice now. So here we have Charles over here, we have Ian, we have Egbert, who just came in, I think. I thought I seen him just come in a minute ago. So I hope I could, he doesn't have a lot of pictures online, so I had to steal that one. And we have Giancarlo down over here. I wanted to regionalize this a little bit more, but I didn't. So basically, let's look at two sort of architectures for looking at this data and how we can kind of coordinate it. One is like a centralized resolver, right? So the resolver I'm calling is really the thing that handles the conflict, and it runs through the set of business rules. Right? And you notice it's not sitting on each machine here. It's actually sitting in one place. Now, theoretically, that could sit on one machine, a master machine, if you will. But in this case, I've got it drawn differently. And the one that we built, we actually used a different technology in between here. So I send information, and every time I make a change, I send that edit up into my resolver. Ian makes some changes. Giancarlo makes some changes. And this server over here is not connected at the moment. Okay? All of those changes get resolved and they go into updates. Then I say, hey, do you have any updates since I last checked? So I last checked at 12 o'clock, that's when I wrote it, and there's no updates. 12:05 or we'll say 12:10, and I check and I got one update. That's the one that came from Giancarlo, right? And it came back in. Even if this connection goes stale, right? It breaks here, it doesn't really matter. they can keep synchronizing back and forth with these edits. And this builds you can call it a dictionary, a library, or a log of all of the edits, of all of those changes. Now, most of those are probably right, but some of them, if I've made changes, will definitely be wrong. Well, possibly wrong, right? So this is interesting. So these guys they get all kinds of information, but I'm offline, and suddenly I go online. I take all of my edits that I've made, and I send them up to the server. The server says, well, I happen to have the latest copy of the update, the latest update piece of information. It resolves all of them. And if anything has changed, it sends me back the updates back into my machine. So my machine synchronizes again. So this may sound complicated, but it's really, really actually simple in practice, right? Really, really simple. This resolver, the code that's running in here, is really just something that's looking through two JSON objects, and it's looking at that timestamp key, and it's basically saying which one is greater. That's the winner, and it builds a new object, and you're done. That's really all that's happening. It's like in JavaScript, it's maybe 15 lines or 10 lines of code, right? You could use any technology you want for here, and this can sit right inside. You could do this right in FileMaker between two different machines. We'll talk about that in a sec, right? We actually use Google Firestore for this, and we just wrote a function for it so that all of these 20, 50 devices can all ping into the server, and they just all resolve. One other thing here, too, is with the updates, these updates that you build, this dictionary that you're building, or this, not really dictionary, it's the log that you're building, it kind of is a source of truth, but it's not really totally the source of truth, because the truth is really changing all the time, right? If Ian goes and suddenly says, I don't want any of those things, I want some other food up in here, then suddenly this information is stale. So it's mostly kind of true, but it's not guaranteed to be the source of truth. It's not like the other pattern where stripe is always the lead here. Right. The resolved data, the data that we resolve here when we take a conflict, just gets stored in these updates. We don't need to keep all of those updates here, right? So we only need to keep the oldest one until the point where we had more or less consistency. In other words, if he hasn't checked in for a week, I have to keep a week of updates. So this stack, if you will, kind of goes down, it kind of builds up, it kind of goes down. We don't need to keep that information in there. We can just prune it off. As long as I know that everybody, like this one here hasn't connected in a bit, so I don't need to, I'm gonna have to keep that data there. Did I explain that very well? Right, so you're not amassing. This is not a replication of these databases. This could be gigabytes, this could be 100K, depending on how often. So it's much smaller on average. Okay, let's look at another scenario. This solution also has the least amount of data in transit as well. This is kind of an advantage here. Because we have this resolver here, the centralized law justice machine here, we are only sending the diffs here and the diffs that change back. That's it. So we're almost minimizing the amount of data that's getting sent. All right, let's look at a decentralized version. It's exactly the same concepts, but just a little bit different. So here, the fundamental difference is we have a resolver on each one of these items. So in this particular case, I send a message to Ian, and he says, yeah, I'm Canadian. I'm just living in the UK, so Charles is a good guy. We're actually just talking about Ottawa, where he used to live, just outside Ottawa. I live in Toronto, and so on, so that's great. I'm going to connect with him. I feel okay. Right? Giancarlo, we're good friends, too. But Egbert and I, he doesn't know me from anybody. He's a stranger to me, so he's not going to necessarily connect, right? And that's fair enough. I can't really connect. I try. Oops, I try, and no, I ping that. But he can connect up to Giancarlo. Maybe he can't for some kind of political reasons or something like that. Maybe he can't connect directly to the UK now, but he can connect to here. And he says, okay, well, this is, my business rules are such that I can allow to do this. So this is an interesting concept here, right? One of the big things here, and I made a little animation, so I'm trying to get past that. He's happy. Sorry. Let's try. I couldn't delete them, so it goes on a bit. Sorry, just give it a second. There we go. Okay. All right. So one of the things here is it's not super efficient, right? It can be efficient, but you have to optimize things, and then it's not like out of the box anymore. The architecture, the data, the way the data travels is not super deterministic. You can optimize things with these routes, and you can use like some kind of, if you've come from a computer science background, was it Dijkstra algorithm? Is that what is shortest path? Dijkstra, I think, yeah, I don't know, something like that. Yeah, I think that's what it is. Anyhow, it's the shortest path algorithm, and you can kind of figure out how your data is going to travel. But the bottom line is, the edits go here, the edits go here, the edits go here. This one just sends the edits back out. And you can, depending on your little tables in here, if you want to build something really complex like this, you can basically say, I'm only going to send the edits out if they're past a certain time. I know he's got the edits up to a certain time, so I don't need to send him the stuff that everything that I get, because I keep an index of when he last got data, right? So I can kind of do some stuff like that, some optimizations. So you can optimize this reasonably well. The big advantage is the network, you can actually make this break. You could add another device node here, node here, node here, and you can have it fish the traffic through. As long as it has an index of who, or an address table of where everybody is and who the people are involved, the players are, you can send that data. And you imagine just in FileMaker, you just loop through and more or less do insert from URLs. All right, so this is how we sort of can build some of this stuff out. Again, I don't want to get into the real tons of code, but I'll show you the concepts, and then hopefully it's enough that you can kind of lead out. I can't share 100% of the stuff that we did because that is proprietary, but this is all pretty public kind of stuff. So basically what we need to do is to build it out. We need to have something, right? We need to have this one fundamental thing. And this we actually wrote this just before we got this guy here on window transaction. We actually developed this. And then that came out, and that was like, stop the presses. Let's change how we do this. We can simplify our code quite a bit. So we need a mechanism, and not all databases do this. FileMaker, I guess, does it technically internally, but it doesn't do it externally easy. We couldn't do any kind of broadcasting. We couldn't send messages out at low-level events up until just recently. But now that we got this on window transaction, this is a really, really big thing for this kind of stuff, because at a very low level, we can jack into FileMaker's operations on anything in the system, and when something changes, we can invoke an event on that. The other thing that we needed, and this came out, I think, I'm not sure what version this came out in, some version buffs, probably no, but get modified fields. I know it's not in 18, so I think it's in 19 that this came out. And this is a real killer one too, because you don't want to always, pardon me? It's 19? Yeah, okay. I know I got a really old Mac at home, and I have to get my laptop out every time I want to do any of this. The rest of the stuff I can just use my old Mac. So I'm trying to get another year or two out of it. It's about 12 years old now, and that one only runs 18. So this is really, really key, because we don't want to send every piece of data that changed in the database. All right, the other side, they only want to know first names and last names. They don't want to know modification, timestamp. They don't want to know the notes, or there's a whole bunch of other fields in your 50 field-wide tables. Maybe 10 fields actually need to be synchronized. We want to minimize that data. So by getting modified fields, we can now not just blindly send the entire object to the other side and let them worry about it. Right? We can just send the stuff that changed. Really, really key. Filters are really important as well. So we want to be able to filter that data. We don't want to be able to send, again, everything. We want to send only these certain fields. From this table, I want to send a couple here. From that table, I want to send some more information. From this table, nothing, and so on. But the on-window transaction runs for everything. So we have to be smart, and we have to be able to pass in data. And this is a tricky part. We have to be able to pass in data from the actual transaction into the thing that's going to process the transaction, right? And be able to have enough metadata there to know what fields changed, and so on. Can centralize. I'm not sure what that means, so I'm going to skip that one. That's the truth. All right. So let's create this custom function, right? So this is a kind of a complex custom function. We're not going to run through the details of it and stuff like that, but I will make this file available for you, and I'll do a quick demonstration here, and I'll make the file. How are we doing for time? Not too bad. I'll make the file available for you in that download area that we have on the site. It's not there now, okay? So the custom function, here it is here. Yeah, you can memorize that. You can take pictures if you want, but it is available. But fundamentally, let me just give you the real gist of what's happening here. Right? Basically, ahead of this, when the window transaction runs, we're injecting some metadata. Now, there's a couple things I glanced over, over when it comes to syncing, is context, right? You have 10 devices. You don't want to sync every change in the database to all 10 devices. This is crew A, crew B, crew C. You only want to send information to some of those. So how do you know the context that you're going to send this out to? That's kind of tricky, right? So that means you need to know the context of that information change. Now, when I build usually systems, I'll do, say, like a documents table, and it's a table with containers, and it's only one table, and there's no other containers in the system, and then it has a foreign key, or actually, yeah, it has an ID of the entity that it came from. This is ID for the contacts person for an avatar. This is ID for an invoice for maybe the printout or something. So it has a foreign entity or an ID key. Now, if I change that in one space, that means I need to notify maybe a certain person on crew A, right? But if I change it from another area, I need to notify somebody in crew B, and that's really, really hard, right? So you need to be able to pass some context information in here. And when you take apart this function, that's basically what we're doing, is we're passing some context stuff in here, and we can even override it. So you can override it in the definitions and override it where it changes inside the app. We're also doing a couple other little things here. We're just doing a SQL query to grab a configuration object so that we can globally configure what data gets synced. We don't want to just hard code it because it's going to change, right? So we want to globally configure it. And more importantly, we're looking at this for a product, and the cloud editor part of the product, it actually controls what fields get synced. So you do that from a web interface, but that's kind of wrapper on top. This is the fundamental concept here. And then basically it continues, we go on, we get all of the fields in the original list, we find out what fields changed, we do some looping over some things, and basically we end up with an object. And at the end of the day, what this thing does is it produces that nice, clean edit object, right? And it does it in such a fashion that you can control anything you want to sync and from any context without touching any of the code. So it's universal. The file is actually named plugin because technically it's a plugin, add-on that you can add on. So that's kind of the gist there. And let me just show you here. Let's just show you just really briefly. So here is this is a jobs table. It doesn't have very much information for a job, is active, features, status, and so on. And over here is a edits table. So this one on the right has all the edits, the data with that information, that resolvable information. And the one on the left is just a dumb table, or just a silly table, or whatever you want to call it, that has some things. So I'm going to change some stuff. I'm going to change the status to active. And I will change. I'm squinting very badly. Features. This is features are bedroom. I don't know what it is. Some job features. And so I changed two fields here. Okay. So you see, as soon as I committed that, then what happened is a record got created here. So let's have a look at that record here. I'm just going to format the data so you can see it a little bit better. And if we look here, let's look at what we got. We're passing a little bit of extra information here. This is just for more specific to a use case. The context information is not set in here, but normally this would be an array of context. What I mean by that is, remember we said something is crew A and crew B and crew C, and you're synchronizing to all of these different crews, right? That's really hard to determine what data gets synchronized. For example, if they're grabbing a part from a parts database, that part database goes to everybody. But if I just update my invoice or my task, I don't need to have the other crew get that data synchronized. So that's what that would have. This would have an array of context, which is an array of, they would literally say crew A, crew B, crew C, or probably the IDs of the crews. The table that it came from, it's called WebSync Jobs. This is just because this is fashioned as a add-on, so that means we want to be able to identify all of this stuff. So it's just called WebSync Jobs, but it'd be like a jobs table. And this could be any table in your system. Here's the stuff that changed. Here's some timestamps of when it changed, right here. And here's the two. These are in sorted alphabetically. So this is the bedroom that I wrote, and the status is active. Oh, and this is one last key piece of information. It was an edit, right? Could create updates, right? So it could be a record creation or it could be a deletion, right? Deletions have to be handled in the same fashion, right? So that's kind of how that works. And if I create another one, if I just change this active to on hold, and the minute I click out of there, we created another one here. And you can see that this has a little bit less information in now, right? Now we only have, can you see that okay, actually? There. Now we only have just one bit. So we have smaller piece of information. I don't know if you guys do this. This is somebody, I don't know, some old guy developer taught me this when I was younger, is to, preface my IDs with a table. So if I see it floating around in the wild, I'm not like, where is C2F76 from? Right now I have a good idea. It's just kind of a trick, right? I think it's kind of handy. So that's kind of the gist of it. Now what I do is I take this information, and now in this particular demo, we're just logging it into here. So we have a list now. I know exactly what changed here. If somebody else had the same file, we'd know what changed on their side. All we have to do now is we have to resolve these. You can build your own resolver, and literally what it's going to do is it's going to iterate over all of the keys and the timestamp, find the corresponding one in the other one, pick a winner, if this is time-based, pick a winner, and then create a new object for that, right? So it's one loop. You can build it into a custom function and feed the 2 items in, or you can build it as a external service, or you can build it as a script that manually does it, whatever your flavor of coding is, right? But it's not too hard. And by doing that, now you have field-level, conflict-free synchronization. That's the concept. All right. Okay, I want to just mention a couple other things here. And this is, again, this is going to be a bit of a weird concept, but your system may not always have the most accurate, I can't find it, may not have the most accurate data. So that means, I'm just going to jump back a little bit here for a second. When we have something like, it doesn't matter what the architecture is, something like this, say, data can be floating. As things go on and offline, you could find that the first name field could change and then change it back again. And you may have used apps like Notion that you might have saw even a flickering of the data when your app comes back online. This kind of concept is used by a lot of systems. CRDTs are used by things like Google Docs for managing the serial, when you're working on collaborative interfaces, like how do you keep all of that stuff in sync? It's really challenging. And so on. So that means you can take these packages. Now, this is the nice thing about this. You can take these updates, and it doesn't matter what order they come in. You can get them like tomorrow. You can get them right away. It makes no difference. It won't bugger up your resolution because they're all time-stamped. It's resolvable, and it's always conflict-free that way. So that means the data might change, but it'll eventually become consistent. It'll eventually become accurate. So I want to jump to the end here and just mention a few things that I didn't cover today. So I didn't talk about the transport layer too much. That's a mechanism that you're using to communicate because every sync is different. Maybe you're synchronizing and you're actually connecting through a FileMaker connection from FileMaker Go to the cloud, and maybe you're doing something like that. Or maybe it is through an API. Right, so something like through Claris Connect, or Better Forms has a built-in API, REST API as well. Or you're using REST FM, or is REST FM, FM REST? REST FM, I think that was one of the quick questions last night. Right, so maybe you're doing something like that. Maybe, and this is what we ended up doing, you're using a web technology, and you're actually communicating through the web portal between 2 devices, and we're using that as the conduit. So it doesn't really matter the mechanism, but I didn't really talk about that too much. I didn't talk about containers. So how do you handle containers? Anybody know? How would you do that based on this? Without flooding all the data. That's the trick.
Use a CDN and links to your container.
Yeah. So you take the file and you just, it doesn't matter what device, it throws it up to S3. And then if you throw it up to S3 and you put it in a deterministic way, so you have a folder based on an ID or some mechanism that you know where it's going to be, you send that up. And you just have to pass that little bit of metadata now, right? The other device can just pull the data down when it needs it, if it needs it, right? So that's containers in a nutshell. If you want to bulk, if you do any web development, if you want to bulk, get data into FileMaker faster, right, on FileMaker Go, we can get it in about 5 times faster than you can with insert from URL. What we do is we open up a web viewer, and we pass all the links into the web viewer. We pull them all down in parallel there because HTTP can do that really well, HTTP2 faster. And then we grab that data and we pass it through a script into FileMaker. That's kind of the secret sauce of doing that if you want to do something like that. I didn't talk about bulk hydration. This one's a hard one, right? So how do you empty database, full database? Nobody's making any edits, but I need to get everything over here. So what do? Do you go to every field and write it, and that creates an edit object? You can sort of do something like that, but you can also just take copies, or you can have some other type of algorithm there. And I didn't talk about consistency checking, and consistency checking is an interesting thing. One of the common ways is a Merkle tree, where it's basically a bunch of checksums, and you just compare at the top, and you say this. Oh, these ones are, oh, this is right, this is right, this is wrong. Oh, there's a wrong one. You go down the tree, and then you pass just that data. That's kind of a technique. There's probably, when I did some research, I think there's like 8 algorithms that are all kind of similar and very designed for very different use cases there. But the Merkle tree seems like the one that would make the most sense for looking at consistency checks, right, between 2 different things as well. All right, if you want to get a hold of myself or our team, you can reach me at Delfs, Delfs Engineering. Our product is FM Better Forms, and my Git is Delfs Engineering. I will put this file that we just demonstrated that's got all the secret sauce stuff in it. I will put it up on Git. I will warn you, though, it has a bit of other stuff, not much else. It's pretty clean because it's a plugin, but it has a little bit of extra other stuff because we have that web. We're using the web as a conduit, but you can just use an insert from URL right to the other machine, just the same way. Exactly the same. I have always thrown this up there. If you ever want to pair code with me, 1-for-1, like, pick a project that you want to work on 1 hour. My project, you'll have to listen to me for an hour. That's the punishment. But maybe we can help each other. The door is always open for that because I've real strong advocate. Our team, we do a lot of pair coding together. And except for Andrew and I, he goes too fast. This goes too fast, right? But yeah, we do a lot of pair code. I'm a big advocate on that. So if you want to hang out, just by all means fire me off an email, and we'll set up a time as well, right? And I hope you build some awesome ideas, and that's synchronizing. Thank you.